Hello, dear students. Once again, welcome to this YouTube channel. Today, we have to discuss chapter number 3, that is motion in a straight line. Means the object is moving along a straight line. See, in this mechanics is the oldest and most fundamental of physics. It is very common physics, and even physics starts with mechanics only, we can say. Mechanics is the study of rest and motion of the objects. See, this mechanics is divided into kinematics, kinematics is Greek word which means motion. Kinematics is a study of motion of bodies without any knowledge of cause of motion. In short, we can say in this branch we are studying our study of motion without knowing the cause for its motion. Okay. So next one is dynamics. Dynamics is a Greek word which means power. A dynamics, we study the causes that are responsible for producing motion of bodies. Especially we can say the main cause of motion is the force. Okay. So with the knowledge of cause of its motion called dynamics. And one more branch, statics. Static means rest. Statics deals with bodies at rest or at equilibrium under the action of forces. Under the action of forces. If the body is acted on the body, number of forces are acted on it, but the body is at rest, we can say it is static equilibrium. Okay. So now let us to discuss these two important terms. Already all of you know about rest and motion. Okay. ಚಲನೆ ಮತ್ತು ತಟಸ್ಥ ಅಂತ ಏನು ಕರಿತಿರಲ್ಲ, ಸೊ ದಟ್ ಒನ್. ಓಕೆ. ರೆಸ್ಟ್. ಸಿ, ಎ ಬಾಡಿ ಈಸ್ ಸೇಡ್ ಟು ಬಿ at rest when it occupies a certain position relative to other bodies and does not change its position with the passage of time. See, suppose a pen is kept on table. Now we can say that pen is at rest with respect to that table. Okay. See, one more term, motion. A body is said to be in motion if it occupies different positions at different times with respect to surroundings. Cleared? So, if the position of the body changes with respect to its surroundings, then we can say that that object is moving or changing their position, or simply we can say it is motion. Is it clear? So simply motion means the body changing or changes its position continuously with the passage of time. Okay. So now let us to discuss the types of motion. Types of motion. See, the name of the chapter itself, motion in a straight line. Okay, the motion along a straight line is called translatory motion or one-dimensional motion. Means the object is moving along a straight line or along the same line. Then we can say that motion is translatory motion. Translatory motion. Next one is rotatory motion. That is motion about a fixed axis. You can take one example of this rotatory motion. See, when the object is in circular path, that fixed point is called center, and the particle is, we can say it is rotating. You can take one more example. When the fan is rotating, so what happens? The particles on its blade are moving, and we can say the particles are moving, but that will come to the same position after one rotation. Okay, so this is because of the body or the particles which are rotating, and that motion is called rotatory motion. Rotatory motion. Is it clear? Okay. Now one more, oscillatory or periodic motion. Oscillatory motion or periodic motion. Motion about a fixed point. Motion about a fixed point is called oscillatory motion or periodic motion. For example, you take one simple pendulum. Simple pendulum means the massive object which is suspended with the help of thread. With the help of thread, if you distribute, so what happens? That massive object will be start motion. But what happens? It will not rotate. Only it will move for some certain means part of the circle and again come back. So here we can say that pendulum is oscillating. It is not rotating, it is oscillating. And also you can take one more example for this oscillatory motion. You take one tuning fork. Okay. When the prongs of the tuning fork are disturbed, so then what happens? That will get, or the prongs will be vibrating. So its motion of the prongs is, we can say it is oscillatory motion. Okay, there are a number of examples for oscillatory motion. So these three types of motions are cleared: translatory motion, rotatory motion, and one more is oscillatory motion. Okay, so let us discuss the next term, distance and displacement. Already all of you studied in your 9th class distance and displacement. See how to measure this distance and displacement. Suppose a body starts its motion from A to B. A is the initial position and B is the final position. So what happens? We can say the body is get displaced from A to B. Then how to measure the distance means how that body is moving. So you have to measure the length of its path. Then you will get the distance. And the distance is a scalar quantity and its SI unit is meter. Okay, and the distance, the value of distance cannot be negative. For example, a body travels from A to B, and if you measure the distance as 5 meter, if the body travels from B to A, then also the distance traveled is 5 meter only. Cleared? So then come to the term displacement. Displacement. See, simply you have to remember, we are measuring the displacement means, suppose the body which travels from A to B, and we are measuring the displacement. We are measuring the displacement means it is the shortest distance between initial position and final position. Okay, and one more thing you have to remember, it is a vector quantity, means that start point and end points. Okay, from, suppose the body travels from A to B, then we can write AB vector, and suppose the body travels from B to A, then we can say BA vector. So BA vector means the body starts from B and ends at A. A to B means starts at A, ends at B. So like that. Cleared? And suppose the body travels from A to B. If you measure the path length, suppose we will get 5 meter. That one is the distance. And the shortest distance between A and B, suppose it is 4 meter. Then we can say that displacement is 4 meter. Okay. So if the displacement from A to B is 4 meter, then from B to A is also 4 meter, but it is negative, then we can say it is minus 4 meter. The direction is very important in this case. It is the shortest distance along with direction. Then we can specify, or we can write the displacement. And displacement is also having the same unit as that of distance. And one more thing you have to remember, if the particle moving along a straight line, along a same line, then if you measure the distance and displacement, you are getting the same value. Cleared? And you have to mention with sign for displacement. Okay, and if the particle is not moving along a straight line, then the magnitude of the displacement is less than distance. Okay, magnitude of the displacement is less than distance. Okay, and for the measurement of displacement, only initial and final positions are considered. There is no any consideration how that particle traveled, or in which path it travels from A to B. That path is not important for the measurement of displacement. Only the path is in the measurement of distance. Okay. See, let us to discuss an example. Here a particle, suppose it travels from one point to another point. Suppose the particle travels from Q to P. So now we can say initially the position of the particle is on x-axis, and which is at a distance of 240, and one more, it is final position is at P, which is also on x-axis, and its position is 360. So now how to measure the displacement means, that is change in position. Change in position means final position minus initial position. Final position is 360 and initial position was 240. So the difference will get 120. So this one is the displacement. Suppose in the same example, if the particle travel from P to Q, then the displacement is 240 minus 360, that will get minus 120. Okay, and distance is same in both cases. Okay, remember the distance traveled is called path length. The magnitude of displacement may or may not be equal to the path length traversed by an object. Okay, so these terms are cleared, distance and displacement. Okay, in next class we have to discuss the remaining part of it. Okay, thank you.